All 45 joined, right?
Yes, ma'am.
Okay. Shall we start? Shall we start?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes. Okay, pa. What are the things we have discussed yesterday? Anyone, please? What are the things we have discussed yesterday?
Linked list, ma'am.
Yes, linked list, point, some say pointers. Okay. Then,
Representation of node in linked list, ma'am. How to
yes,
declare that, how to create a node.
yes, is very good.
And
Types
then we
of,
saw the program for insertion at the beginning of the linked list, ma'am.
is very good, very good. Today I'm receiving lots of responses in chat. Thank you. And so saw about types of linked list. What are they?
Singly linked list, doubly linked list, circular linked list.
Yes, very good. These are the types in linked list. And under which topic we are saying about what linked list? Yes. Under which topic we are now seeing about the linked list? What is the root of the particular topic?
Non-primitive data structure.
Non-primitive, no. We are
Linear.
start from abstract data type. Do you remember?
Yes, ma'am.
Yes, very good. Someone replied in chat, Abhishek. Yes, very good. Start under abstract data type. In that, we have some examples, that is list ADT and stack ADT and queue ADT. In this first unit, we just going to discuss about only list ADT. So in this list ADT, how we can implement this list ADT in two ways. One is array and one is linked list. Okay. Linked list, list ADT using array already we have discussed. So now we are in list ADT using what? Linked list. Okay. Okay, thank you for your response. This abstract ADT, sorry, abstract data type ADT, and example for that we have seen, and benefits, and then only we come to list and list ADT. How to implementation here, array and linked list. In array, we have already discussed what are the how we can declare and what are the operation we can done. These are the topics under list ADT using array, and saw about issues in array, right? What are the issues in arrays? Why we are moving
Fixed
to,
size, ma'am.
yes, we can resize the particular memory, but it is very expansive. Okay, next one. Any other?
Wastage of memory space.
Yes, very good. Next. Next.
Continuous memory allocation is required, ma'am.
Okay, fine. What about insertion and deletion?
Inefficient, ma'am, it is.
Yes. Why it is inefficient? Why it is inefficient? The insertion and deletions are
Because
in.
elements are shifted.
Yes. Once we are doing with insertion, then we have to shift our remaining elements towards right. Once we are going to delete a particular element, then the remaining elements are going need to move towards left. This is the process happening in insertion and deletion. So it is very inefficient. Okay, fine. Then now only we are coming to the linked list. What is my linked list? It is a linear data structure in which the elements are stored under contiguous memory locations. The elements in a linked list are linked using pointer. We can store anywhere, but the what is that? We can connect through the links. Okay. How we can create a link means with the help of this address of next to location. Address of next value is stored in the previous node. In the linked list, the elements is represented in the form of node. In this node, we have two fields. What are they? Yes, please. Linked list, we
Data
have.
and pointer to next structure.
Yes, very good. Data and address value. That is the point. One is the data field. Next one is the address field or a pointer field. Otherwise, we can say the reference field and next field. Okay. These are the names for the particular second field. One is the data field. Next one is the pointer field, which is used to store the address of next location. Okay. This is the linked list ADT. This is an example for that. This is the representation of node in the linked list. How we can represent here in this node, particular node having two field. One is the data and one is the address. Data we can denote as the integer data type, and address we can store by the pointer data type only. So we have to combine these two under one node. For that we are using structure concept here. What is maybe structure?
It contains
Alexa.
different data types.
Yes, it is a user defined data type, which is combination of different members with the different data types. Okay, this is the structure concept. Using this structure only, we can represent this node. Okay, what is the keyword for structure?
Struct.
Strut. Please, others also please respond. You can respond, unmute and speak. Otherwise, you can respond in my chat also. Okay. So with the help of strut keyword, we can declare the structure data type. In that here we need to declare, we have two elements. One is data, one is address. So we are declaring like this is the strut keyword to declare the structure data type. This is the name. Node is nothing but this is the name. We can give any name here. Strut A, strut B, anything we can give. Okay, this is a keyword and this is the name. Within that we are declaring two elements. One is data. The data is in the form of integer data type, and next one is the address, that is the star next. Here I can say any name. Star, this is one of the operator which is used to denote the particular element is a pointer data type. So here I am using this asterisk symbol, and this is a name for that particular element. We can give any name, asterisk new and a b c, anything we can give. This is the, what is the stat node is the referential pointer. Here it, this address is denoting the address of itself, that is the address of the same node. So it referencing the, what is that, referential self referential pointer. So we are using the start node. It is the type of start node, and so this star next having the address of another node, right? Another node means, and so the node is combination of, again it is a combination of data and address. So it is denoted in the form of start node. Finally I'm closing the start data type. This is the structure concept we have used here. Then next one is the creating a node. Now declare the node. Now I'm going to creating a node. How we can allocate the memory for structure? Yes, please. How we can allocate the memory for
Using
structure?
MLOC, madam.
Yes. Why we are moving to MLR? Yes, please. Why we are going to allocate the memory dynamically for structure?
It allocates dynamically, ma'am.
Is it allocate dynamically, and so we don't know idea about how many elements or how many nodes are going to be a part of in the particular linked list. We don't know. That's why we are going to allocate the particular memory size in dynamically. For that we are using mloc function. This is the function which is used to allocate the memory dynamically for a structure. Okay. So for this mloc function we have some syntax. One is we have to first of all we have to pass the what is that return type and mloc function, again argument. What we go which one we going to allocate memory, like that we can give in the argument. Here we are going to allocate the memory for a particular structure, so I'm giving here size of start node. Okay, is it clear everyone? Is a very important topic, that's why I'm telling again. So mloc, in this we can pass the size of start node. This is the return type. This is the return type. We need this return. And what is the result of n? What is the value stored in n? Please, anyone? This n having which value, or what is that in n after that after this code run? What is the value in n? Anyone, please? What is the value in n once the code is executed? So once the
Structure, madam.
what? Ma?
Structure, madam. Entire structure, madam. Address of the
No.
structure.
Yes, address of the particular structure. Address of particular this structure node is stored under this n value. That is, maybe I going this function may allocate some block of storage for this structure node, means it is start from 1000, means this 1000 is written by this n value. Okay, once it allocate, after it give the return value as starting address of particular location. This is the n value. So again again I am declaring with one variable. This is nothing but variable for this structure. With the help of this variable only we can access particular members within the structure. So with the help of this n uh, here I am declaring the pointer variable. Why means it is this variable need to access both data and also the next field having the address of another location. So for this address I am using this n as a pointer variable. Once we are doing with a pointer variable, means with the help of this arrow operator only we can access the particular data members inside the structure. Okay, is it clear everyone? Here I'm declaring the pointer variable, so I'm using, I can use only the arrow operator to access the particular member inside the structure. So here the address is allocated dynamically, and I can how I can access the data means n arrow operator next equal to null. That is now I'm just creating a only one node. That is, this is n node. Okay, this is n node. This node only after executing this code, this node will be created. So for that, in this case of next field, I'm just putting the null. Okay, this is only one node in linked list. So I'm the next this is denoting, this symbol is used for denoting particular node is the last node or tail node, like that. Okay, so how I can fetch the data member? How can I fetch the data member? Yes, I'm
Using the arrow operator, ma'am.
yes, that how n
Arrow operator and then the data, ma'am.
yes, n arrow operator, then data. Within the data I can assign any value. That n arrow operator data equal to 10 means the 10 is stored under here. Okay, this is the process happening here. Is it clear, everyone? Any doubt? Please ask me. Any doubt? Is it clear? Please give me a response. Any doubt?
Ma'am, their null is written, no, ma'am. It is because that n box is empty, or it represents that the pointer field is empty, ma'am.
What is that, ma? You are
Ma'am,
asking. Yes.
null is given, no, ma'am. It
Yes.
represents that the data field is empty or the pointer field is empty, ma'am.
Pointer field is empty. N arrow operator next equal to null means the pointer, I mean this node no longer accessing another variable. Okay, this is the meaning. In the case of data field, we didn't give anything, means some garbage value will filled. Otherwise, if I am giving n arrow operator data equal to 10 means the particular 10 will stored under data field. Okay.
Okay, ma'am.
Okay, pa. Is it clear, everyone?
Yes,
Give me
ma'am.
a yes. Others?
Yes, ma'am.
Okay, okay, fine. Thank you. Thank you, Pa. Okay. Now, again, going to the types of linked list. In this is the this is the example for SSL, that is singly linked list. What are the operation we can do? Insertion, deletion, and search operation. These are the main operation, and we can display the operation and reverse the particular list. Likewise, we can do. These are the main operation under singly linked list. This is the global. Again, this is nothing but already we have discussed. This is the declaration part. Again, I come up with some more variable. That's it. That means that this is a one variable which is used to denote the head node, and it is used to do tail node. And again, it is I'm declaring one node to represent the temp variable. If I need to change anything or remove anything with the help of this variable, I can do. That's why I'm just declaring some more variable here. This is the global declaration of nothing but I'm going to develop one program. That's why I'm doing some more variable. Before I saw that we saw that that is the just syntax. Now we are moving to particular program. Okay, this is the global declaration. Just here I am declaring some other variables. Okay, now I start with insertion at the beginning of the list. Here only I stopped yesterday. So insertion at the beginning of the list, how we can do means first we know we'll see about what are the possibility we can do. First, going to insert one node in the beginning. So if the list is empty, what will be happen? I'm going to insert one node in the linked list, but no node in the linked list. That means no more any elements in the linked list. Then what will be the what will be happen? I'm going to insert one node in the linked list. Okay, but the linked list is empty. Then what is the process? Any guess? Any idea? Here I am giving some lines. Yes, please. I'm audible.
Yes, ma'am.
Then tell me, Pa, if the particular linked list is empty, then how can I insert a node?
Using positions.
What? What, Ma? Yes, tell me what. Hello, I'm audible.
We should create a new node, ma'am.
Yes, it should create a new node with a particular. Sorry, it is. You should create a new linked list with a particular node we are going to insert. That is okay. If the linked list is empty, then I'm going to insert a particular node. Means that particular node only be in the part of linked list, no other nodes. Okay, so if the list is empty, then simply make the start pointed towards the new node, which node we are going to insert. That node will be in the head node of the particular linked list. Okay, this is the process. And if the list is not empty means what will be the procedure? here see please, here in linked list I'm having 4 nodes, that is A, B, C and D, 4 nodes. I'm going to insert another one node in the starting position, that is the node E going to be insert. Then what will be the procedure? Tell me. In this diagram you can infer what is the procedure. Then linked list is not empty. Some elements, some nodes are there in the linked list. So I'm going to again here I'm having 4 nodes A, B and A, B, C and D. Now I'm going to add another one node, that is E, into the particular list at the beginning of the list. Then what is the procedure? Please tell
First, we'll
me.
The
make
point.
the new node as the head node, madam, and then we'll make it point to the first node.
Okay, fine. This is the process. Okay, is it clear, everyone? First, I'm going to assign a particular new node to the head, and that new node, the next pointer, that means the next field of that new node is pointing to the first node. That means the previous first node of the linked list. Then it will be connected to the particular linked list. This is the process. Then how we can implement by this program? Okay, that means if the list is not empty, make the next pointer of the node point towards the first node of the list. Is it clear? Make the next pointer. Next pointer means make the next pointer. This is the next pointer. Okay, make the next pointer of the node point towards the first node of the list. This is the first node. Already we have just how these are the nodes under the linked list. So this is the first node, this is the last node. Now I'm going to insert this. So which one is the new node? In this new node, the what is the next pointer? Next field is pointing to the first node of the linked list. Okay, this is the first point here. The next one, make the start pointer point towards this new node. That means start pointer is nothing but the head node. Head node is pointing towards the, this is the first node. This is the process. Okay, we can implement in the case of if the linked list is empty, means which node we are going to insert, that is the head node, and this is the first node. This is the only node in the linked list. If the list is not empty, then how we can do next pointer of the new node, next pointer, next field, that is this is the next field. Next field of the pointer is pointing towards the first node of the list, and then the head node is denoting to the new node. This is the process. Then we will see how we can implement this. Okay, for that I'm going to write one function. What is that? Void inserting at the beginning. So I'm giving inspg. We can give any name. In that I'm passing one argument int num. This num I assume here in through this program I'm assuming that is let num equal to 10. I'm going to insert 10 into the particular linked list. Okay, this is the linked list. The first diagram shows the linked list. I'm having 3 nodes in the linked list. So the first node is in the location, that is 1000. The memory location for second node is 850, then 1500. This 850 is stored in first node. Okay, the 850 is stored here and 1500 is stored here. This is the linked list. This is a head node and tail node. Now I'm going to insert particular node, that is with the value of 10. Okay, I'm going to insert one node with a value of 10 at the beginning of the linked list. That is, this is the node having value 10. I'm going to insert this node here at the beginning of the linked list. Okay, this is the process. Okay, have you understood? So far, is it clear, everyone? I'm having one linked list. In that, I'm going to insert one node with a value of 10. Okay, going to insert. Now the procedure is, for the first we have to declare creating a node. We have to we have to create the particular node, right? Which node we are going to insert? This node going to create now. That is that these three line already we have discussed, it is used to create a particular node. With the help of this line, I allocate the memory. In that, I am declaring the next field is null, and the data is what, that is num. In this num, I am just assigning the value 10. Okay, now clear. A particular node is created. Is it created? Yes. Now the node is created with a value of 10. Okay, value of 10, then the pointer value, that is the next field is what here, null. I'm declared, okay, n arrow next is null, that is only created here. And what is the name for this node? Any name I given here? What is the name for this node? Yes, any name for this node I have created?
N, ma'am.
Yes, very good, ma. This is the name of n. What about others? Is it clear? Are we all of you able to follow me?
Yes, ma'am.
Okay, please respond. If you have any doubt, please ask me. It is very interesting only, I think so. It's very interesting in some other in further topics also. So lots of interesting on that. So please listen. Without understanding, you can't go with programs, because it is a single program may have some 70 and 80 lines. We can't memorize, or we can remember that. So if you are understood this means, then it is very easy, just go through and you can write the program. Okay, so please listen. This is the routine for insertion at the beginning. Now I have created one node with the name of n. Okay, and the value is 10. The address field is empty, that is null. Okay, now I'm declaring one if value, if loop. In that, going to check the head is equal to null. Okay, what is the meaning for that? What is the value in head? What is the value in head? What is the value in head? Please.
83.
Yes.
83, ma'am.
Okay, fine. This is the value in head, right? So we are going to check the particular value is equal to null. That means if it no more field, I mean no more node in the linked list, that is the list, whether the list is empty or not. Likewise, we are going to check. For that, we are doing this process. Now I'm checking whether the linked list having any node or not. The head equal to null means what is that? What is the meaning? Head equal to null means what is the meaning?
The pointer field does not contain any address.
No, not about pointer field. No other node in the linked list.
Okay, ma'am.
Okay, I'm not going here. I'm not representing any next field, not a next field. Totally, I'm representing as head node. Okay, this head node is equal to null means no other node in the linked list. So the list is empty. Just I'm assigning the new node as head and new node as a tail. Okay, is it clear, everyone? First, I'm going to check the whether link. I'm going to insert one element into the list. Before that, I'm going to check whether the list is having some elements or not. Without if the link list not having any element means the new node which is comes first, which is going to insert, that is the head, that is the tail. Okay, so there is only one node in the linked list, that is where inserted one. Okay, so this is the case. I'm here. This is the case I'm checking here. Does the head is having null value or not? If it is null means the linked list no more having any nodes, otherwise it have some nodes. So if the condition is true means it will works. If the condition is not true means then it go to the else part. In this case, the condition is true or not? True or false?
True.
For
Huh? Yes. True or false?
false, ma'am.
Yes.
False.
Yes, very good. False. Not true. I'm checking head equal to null. But here I'm having some values in the linked list. That means the three nodes are there. So this condition is false. So it comes to else part. Okay. In this else part, what I'm do? N pointer next. What is that? N means which one? N means which
The
one?
node which we have created.
Yes, the node which have created and which we want to insert into the particular list. This is the n. N arrow operator next means it is denoting what? What? Denoting what? N arrow operator next means? Yes. What is the meaning for that? N arrow operator next. N means the new node. Okay. Next, the arrow operator is used to access the particular members. Then next means which one is the next field?
Pointer field.
Point.
Yes, yes. This is the next field. Okay. Uh, in n node, this next is nothing but n arrow operator next means it denoting this pointer field. So I'm assigning n arrow operator next. The assigning, what is that? Head is assigned to this pointer. That means where this is the new node I'm having. If the list is empty means this will happen. This is the if part, that is the new node will be the head and also it will be the tail. Otherwise, if list having some elements, then move on to the this diagram. And now I'm having the elements of three nodes, so I'm moving here. That is n arrow operator next. That is the next field of n assigned to head value. Okay, the head is assigned to here. That means the address is assigned to here. This is the need to add with a particular address, that is 1000. Okay, okay, is it clear? So again another one line is there, that is head equal to n. What is that meaning for that? N is assigned to head. Yeah, what is the n now? Now what is the n?
Head node, ma'am.
What is the n? The new node we are going to insert, right? This is the n. Now that n will be assigned to head value. That is head is now here this is not a head. Now the head is moved here. That means the node which we are inserted will be the head. Okay, why means it is the beginning of the list. So which one is which node is the first one? That is the head node. Is it clear, everyone? Any doubt? Is it clear, everyone?
Yes, ma'am.
Okay. Boys?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. Thank you, Pa. Thank you. Oh, this is the process we are inserting in one node at the beginning of the linked list. Okay. Shall I move on to the next one? Is it clear? In this insertion part, just I am declaring one, defining one function, and with the help of these three lines, first three lines, we can create a node, new node, and again I'm checking if the head node is null or not. If the node is null, that means the uh, uh, where I'm going to insert the element. Particular linked list is null means the new node is the head and tail. It is act as head and so the tail. If it is not in the case, then next to node, that means the previous head node is assigned to the new node. I means the new node will be going to be head for the particular linked list because it is inserted in the beginning of the list. Is it clear?
Yes, ma'am.
Okay, ma'am. Okay, now I'm going to insert a node at the end of the list. How we can? I'm going to before that we have seen that We can we insert the element at the beginning of the list. Now I'm going to insert the element at the end of the list. How we can, here have some lines and also diagram. Please refer and tell me. I need more response from you. Please respond me, then only I can know whether I'm going in a right way or not. And it is easy to follow you, or like I can come to know. Please give me a response. How we can insert the node at the end of the linked list?
Ma'am, we should include the address of the node which we want to include at the tail node, ma'am, and then the tail node should be changed, ma'am.
Change to?
The node which we have created, ma'am.
Okay, fine. This is the process. Okay, is it clear? What about boys? No other response from boys today. What's happening? Are you able to follow me?
Yes, ma'am.
Okay. Okay, but this is the process. We are just normally in the tail node, we don't have any pointer field. That is, the pointer field will be null, right? So I'm removing the null value and insert another one address into the null node, null value. That is which node we are going to insert. That address is assigned to the null node, and then tail node also changed. Change it from previous one to newly added node. This is the process we are going to do now. We simply need to make the next pointer of the last node point to the new node. We simply need to make the next pointer of the last node. Last node means this is the last node. Okay, this is the last node, and next pointer means this is the next pointer. Okay, this is the next pointer is after point to the new node. It is going to point to the new node. This is the process. Okay, how we can do with that means, an example, I'm having, this is the linked list. Now I'm created one new node. I'm going to insert this new node in the end of the linked list. That means here I'm going to insert. Okay, here I'm going to insert. For that first, and so for, in previous example, here also we are doing one check, that is particular linked list is empty or not. If it is empty, then new node only be the part of linked list. That means that is the head node, that is the tail node. Otherwise, we are going to insert at the end of the position. How we can do means that what is that? Next pointer of next field of tail node. Tail arrow operator next it to be changed to the address of the newly added node. Okay, so again this is the first step, and next step is you have to change the tail node from here to here. Okay, this is the process. Then is it clear everyone? In manual, this is the process. Is it clear? We're having one list and going to insert one node at the end of the list. For that, we are going to check whether the linked list is empty or not. If it is empty, then insert the new node, and that node only be the part of linked list, and that be the head and also the tail. Otherwise, if have some elements, some nodes in the list means we are going to insert at the end position. How we can insert means remove the, it means we can give the address of newly we are going to give the address of new node to the next field of tail node. Okay, so then the next one, we are changing the tail node of, from previous one to newly added one. This is the process. Is it clear everyone?
Yes,
Anyone?
ma'am.
Yes, thank you, Pa. Anyone please explain this process? What is the process happening here? Please, anyone explain. Then I come to know whether you are following or not. Please, anyone? how we are going to insert one node at the end of the linked list. Anyone, please? I'm audible.
Yes, ma'am.
Yes, please explain. Anyone? No other.
Initially, we make the tail node to point to the new node we have to insert, madam.
Okay.
After pointing, we'll make the new tail node. We'll make the new tail node point to null value.
Okay, fine. Who's this? Santosh, right?
Yes, madam.
Okay. Okay, pa. Please, from girls' side, other than Ramya, please, anyone? Other than Ramya, please, anyone? I'm audible. Girls? Girls? Are you there? Are you there? No other girls in the meet, right?
Yes.
Then explain. Explain me what is going here. If you're going in wrong way, then no problem. I will explain again. Hmm? No issues. Please come forward and explain what is going here. Otherwise, I will point out. Who's girls? Are you there? Please come forward. Yes, Priyadashni. Can you? Priyadashni, are you there? What's going? Please respond. Priyadashni, are you there? Yes, ma'am. Yes. Unmute and speak, ma. What is going here? Are you able to follow me? Are you able to follow me, Priyadashni? Hello. Okay, other than Raj, I don't know. You are raising PC means then can't able to speak. Is it? Anyone reply me? You are using PC means then can't able to unmute and speak. Is it? Is it? Boys? Okay, come with Rajalakshmi.
Ma'am.
Can you explain, ma? Rajalakshmi?
Will try, ma'am.
Okay. Okay. Rajeshwari,
Yes, ma'am.
can you explain?
Ma'am, we are inserting a new node at the end, ma'am.
Mm. Very good. Yes. Rajeshwari,
Yes, ma'am.
explain ma. Explain the concept. How we can insert at the end. How we can insert. Hello.
Ma'am, I tried, ma'am.
Okay, no problem. I will explain again. Please follow me. Okay. Otherwise, it is like a big process. If you are understood, then it's a very easy one. Hmm? If you are listening properly and come along me, then it is this subject is very easy. Just you can go through and write the exam. Okay. Otherwise, you need to sit for long time and study. Okay, no problem. Just I'm asking whether I'm whether you are following me or not. Likewise, I need to know. That's why I called these peoples. Other than no reason for that. Okay, we are going to insert at the end of the list means for that, we first create the new node with element. After that, find the tail node and remove the null value in the tail node, and which node we are going to insert. That address is stored in the tail node, and uh, mark the what newly added node. Next pointer is a null value. This is the process. How we can do with programming means, here also the same case, like insertion at the beginning, write on function. In that, we do with particular three lines. It is used to, with the help of these three lines, how we can what is the thing we are achieving, why we are
We are
using these three
creating a
lines.
node.
Yes, creating one node, creating a new node. Okay. In this num means which element we are going to insert. This is the uh, this 10 value is going to insert into the num value. That is the, with the help of these three line. Please listen. With the help of these three line, we are going to create one new node with a value that is here. I am assuming that value is 10, and the next pointer, next field. What is the next field here? What is the next field here?
That's it.
Yes, what's the next field? Null. This is the node we have created here. So after that, I am going to check whether the linked list is empty or not. If it is empty means the new node only be the part of the linked list. This is the tail node. This is a head node. Otherwise, I have some assuming otherwise if otherwise I having some nodes in the linked list. So what is the procedure? Find out the tail node and find out the address field. I mean the next field of tail node. The that means this is the pointer here. This is the denoted here. That is tail arrow operator. Next means next field of tail node. This is the tail node, and this is the next field of tail node. So next field of tail node is assigned to, what is that? N value is assigned to the particular tail node of next field. What is the N value here? What is the N value? Which one is N?
10, ma'am.
What? 10. 10, not 10. The newly created node. Okay. The newly created node is assigned in the N value. That N is assigned to the tail arrow operator next. Again, I'm assigning one value, that is N is, what is N is assigned to tail. So then we are going to insert the node at the end of the position. So the particular newly added node will be the tail. This is not a tail. Tail is marked as here. Okay. So the tail is changed to the newly added node. This is a process of insertion at the end of the linked list. Is it clear? With the help of this understanding, you can write the program yourself. Okay, so write one function in that with the help of these three lines. First, what is that? Allocate the memory dynamically and assign the value for the two field. One is the data field, one is the next field. With the help of these three, we can create one node. After that creating, we have to check whether the linked list is null or not. Likewise, if it is null, just adding the particular new node into the list, that only one node in the list, that is the tail node, that is the head node. Just assigning with the help of these two lines. If it is not in the case, that means the head node not null. Not null means if having the linked list having some nodes in the same linked list having some nodes. So find out the tail node, and within the tail node find out the next field. In that we are assigning the address of the newly added node and assigning the newly added node as a tail node. This is the process. Is it clear, everyone? Is it clear,
Yes,
Pa?
ma'am.
Okay. Okay. Okay, this is the process. And next one is insertion at the middle of the simply linked list. Anyone can explain what is the process? We can go with this insertion in the middle. Anyone please explain? Already explained the insertion at the beginning and insertion at the
Ma'am,
end.
shall I, ma'am?
Who's that, ma? Ramya?
Yes, ma'am.
Uh, Other than Ramya, please explain. She only responded well. Other than Ramya, anyone, please, other than Ramya, please, anyone give give this explanation. How we can insert in the middle of the simply linked list? How we can? Already explained the beginning and the end. Now, please explain the middle. How we can? I'm audible. Anyone in the meet? Is anyone is there?
Yes, ma'am, you are audible, miss.
Okay. Then explain. What's the
First will,
problem?
shall I explain,
What?
ma'am?
Santosh?
Yes, ma'am. First, we'll make the new node to point that particular position, madam,
Okay.
and we'll make that new node to point to the current node which was there previously, ma'am.
Mm. Okay. I come up with a diagram that is we are having the linked list of four nodes, that is A, B, C, and D. Now I'm going to insert the node E into that particular list. How we can? I means I can first of all I have to going with the two process. One is first step is which position I need to insert. That is, we can ask from the user which position or which value. After the which value going to insert. Likewise, we can ask others after the position. Likewise, we can ask the user. With the help of this, I find out the particular position, and then particular next value of that particular node. Okay, after B node, I'm going to insert means find out the next field of the particular B node and insert. I mean, the giving the address of E node into the B value. In previously, the B node having the address of C, right? B node having the address of C, but I'm changing the address into this value, and so that particular value, what is the address in B node is transferred to the E node. Okay, Now the connection will establish. This is the process. That means make the next pointer of the node to be inserted, point to the next node of the node after which you want to insert the node. This is the first step. Next one is the makes the next pointer of the node. Next pointer means nothing but next field. That means the pointer field of the node after which the node is to be inserted, point to the node to be inserted. Okay, this is the second step here. So how we can do that means, first of all, I'm just asking the value which after which element, after which data we are going to insert the new node. Okay, so the new node having the value, that is, I'm going to insert one node that is having the value of 10. Okay, this is the node n I'm going to insert, but where I'm going to insert means in the middle position. And so I mentioned the data after the value, after the value n, I'm going to insert the particular 10th value, the particular n node. Okay, so what is the process? This is my linked list. Okay, this is the first diagram shows my linked list. I'm having 4 nodes with a value of 83, 9, 27, 46. 83 is the head node and 46 is the tail node. This is the input. That is, I'm having the value. I'm having the linked list likewise. So in that, I'm going to insert one node, that is the n node. Okay, which is stored under the 300, which is stored under the memory size, memory location, that is 300. This is the name for the particular node is n, and having the value is 10. This node is going to insert after the 9, after the element 9. Already I given here the mid value. I'm going to insert the node after the element 9. So this is the position I'm going to insert, right? For that, I'm going to check here. I'm going to check whether the here I'm going to check two functions, two condition. What is that means? I'm going to check whether the particular node is head or not, or tail or not. Likewise, I'm going to check from head only. I'm going to start, right? So I'm going to check the head node. After that, check the element also. Why means I'm going to insert the element after the 9 only. So I need to find out the particular node of which having the element 9. So I'm going to check after that. Once I find out the particular node, then I'm going to insert. Okay, this is the procedure here. This is the node I'm going to insert. First of all, I'm check whether the particular node is a head or not. So here this is the 3 line which is used to what, creating the new node with a value of 10. That is the n node I'm going to create. I'm created with the help of these 3 line, and I'm giving again one that is what, for loop. It's here I'm checked condition. It is the t equal to t again. Sorry, here one declaration is there, that is the t. In this global declaration, I have mentioned one temporary variable, that is here I'm used, that is t is assigned to head node. Start with the I'm going to travel through the linked list, right? Why means I have to find out a particular node that is having the value of 9, so that I'm starting from the head value and traveling through the node until what is that, until not equal to null, where we have the node is null, where we have the null value in the node.
At the tail node, ma'am.
Yes, very good.
Ma'am,
Tail node.
ma'am,
Yes.
where we have not declared the T.
Who's this? What is the doubt? Where we are, where
We
we
have not
declared that?
declared the variable
Yes.
T, no, ma'am. because I'm stuck.
Yes. Who's this, pa? Asking.
Rohit, ma'am.
Rohit. Okay, fine. Here I'm declared here. Just I'm now I'm discussing only the logic, not going with the whole program. Just I'm telling previously this is the node. This is the variable I have declared. Okay. This is only for accessing some temporary it is like temporary variable. Okay, just I'm explaining the logic only within the function only. I'm explaining before that function where we need to declare the particular variable t. Okay, is it clear, Rogit? Just I'm explaining the logic here. When once we are going with a particular whole program, then we have to mention all those things. Okay.
Okay, ma'am.
Okay, pa. Okay, now I'm start with what? Head node and ending with what? Tail node. That means mentioned by t not equal to null. Okay, just it is one temporary variable or one variable which is used to travel through the linked list. Start with the head node and end with the what? Not equal to when the loop is come out. When the loop is come out, is anyone when the loop is come out? How many iterations we are going to do here?
When the tail node is equal to null, it will come out,
Yes,
madam.
yes. When the tail node is reached, it come out. That means I'm mentioned here t not equal to null. When the t equal to null means when it reaches the tail node. Okay, this is the condition here. This is the initialization. This is the condition we are going to check. And the increment, in the case of increment, we are doing what? T equal to t arrow operator next. What is mean by that here? What is meant by that? T equal to T arrow mark next means what is that?
The pointer field of the temporary
Pointing
node.
the tail node to the next value.
Notice the temporary, notice the tail. Which node is allotted to T? That means the first node. That is now in first iteration, the T is assigned to what? Head node. So the head node here in the case of T, I'm having the head node. The second iteration, it moves on to the next node. Okay, in first iteration, the T having the value of head node. Here I'm denoting. This is the first iteration. I'm having the T node. That means the temporary this variable is denoted to the head node. Next, it move on to the next node. After that, it move on to the third node. After that, it move on to the fourth node. That is reach until the tail node. It is moving. For that only, I'm using the concept that is T arrow operator next. It means that what is the now for example in first iteration t is here. Okay, this is the t variable is here, that is it is assigned to head node is assigned to t variable. What is the t arrow operator next denotes here in this node? What is the meaning of t arrow operator next? Yes.
The pointer field of that node.
Yes, what is this is the meaning for that particular command, that is t arrow operator next means it pointing to the address of next one, so it moves incremented by one, incremented to this address. And now the second iteration, the t value that is changed to what? This node. Okay, so the t is comes here. After the in third iteration also, the t next is here. It moves to the address of next node. So this is the process happening here in the for loop. I'm start with the head node, end with the tail node. The condition incremented by one. Each one node is incremented with the help of this t arrow operator next. Okay, is it clear? For loop is clear, everyone? Is
Yes, ma'am.
Yes,
okay,
ma'am.
fine. Okay, fine. In that for loop, I'm checking. Again, I'm giving one if loop. It is used to check whether the whether we have reached the particular value where we are going to insert. After the value 9 only we are going to insert. Okay, so I have to find out where the 9 is placed. For that, I'm checking T arrow operator data. That means what? If the T is placed here in the first iteration, T is placed here means what is the T arrow operator data? What is the value?
83.
83. Very good, very good. So in this first iteration, the value is 83. Now I'm going to check 83 is equal to mid underscore data. What is the data here? That is 9. So I'm checking 83 is equal to 9. Is it true or not?
No.
No,
No.
no.
No, so the it is not true. If it is true means I break here. Otherwise, the loop is again executed. Again comes to a for loop. Now the t value is what? T is moved here. The second node. T is moved here. Again, I will check the t is not equal to null. If it is null means it comes out, otherwise it move on. Again the t node is incremented by 1. Again next iteration it moves to here. So in that, in now the t value is in second node. Okay, now the t is in second node. So the value is, what is the value of second node? What is the value?
9.
9.
Mm.
Okay, fine. Now I compared with a 9. 9 equal to 9, right? So the condition is now 9
True.
equal to 9. Condition is true. Okay. So it comes out of the loop. That is that. Again, I'm doing some process. I have given up with some 2 lines. What is that? N arrow operator next. What is the n value? What is mean by n? N is nothing but,
The newly created node.
yes, newly created node. So n operator next means what?
The pointer field of the new node.
Yes, very good, ma. Who's your name? What is your name? Who's this?
Mika. Mika.
Mika. Okay, fine. Today only come up. Okay, this is the next field of the particular newly added node. Okay, this will assign to what? What is assigned to new value? T arrow operator next. Where the T play now which position is T placed?
The
Where
head
the
value
T,
9.
what ma? What? T is in which position now? We have come up. We have traveled through this T value only. Now where the T is placed?
The second node of the list.
No, third node. Once I check the second iteration, the third is incremented, right? T equal to T arrow operator next. Yes.
Yes, ma'am.
Yes. Now it is in third node, that is assigned to the what? The newly added node. This is the process happening here. And again, what is the T arrow operator next is equal to N.
Ma'am, actually,
Sorry. Yes, right. This is in second iteration only, right? Ramya?
yes, ma'am.
Yes. Okay. It is in second only, that is assigned to the newly added node. That means what is that? The address of second node, second point. Address of this is comes to the next field of this newly added node, and this address is stored into the this next field of the what is that, second node. Okay, this is the process happening here. Is it clear, everyone? Any doubt? If anyone from your side come forward to explain, then it is helpful to others also follow me. Is anyone? Anyone, please? Yes, Santosh,
Yes, madam.
can you?
Yes, madam. So first we check for the data value, madam. We check each structure. Once we find the value, we make we make it point to the structure we have to insert, madam.
Okay.
And then that new structure we make it point to the next value of that array, madam.
Previous node. Okay, fine.
Yes.
Thank you. Is it clear, everyone? So far, we have come up with what insertion in the beginning and end and in the middle. Okay. After that, we have deletion operation like this is somewhat easier only. Deletion operation and searching. Up to this, we can complete our linked list. Okay. This is a big topic only. So we have come up with what are the process insertion in insertion at the beginning and end and middle. Is it clear, everyone? Is it
Yes,
clear?
ma'am.
If you have any doubt,
Yes.
please ask me. Don't hesitate. It is once you are understood, then it is very easy for you. Okay. So time is over, I think so. Thank you very much, especially for who are responded me well. Thank you so much. Others also try to respond. Okay. Then only I come to know it is how it's going. Okay. Thank you so much. Thank you, students. Again, we meet on tomorrow. Tomorrow, first hour is there, I think so. Okay, we meet on tomorrow. Thank you. Thank you all.
Thank you, ma'am.
Thank you.
Thank you.
Thank you.